Okay, good morning everybody. Monday morning, whoo-hoo, 10:26. So if you are on Zoom with me, or if you've done Zoom with me, we're going to talk a little bit more about square roots. And if it's a fourth period, then we'll talk about this tomorrow. I would like to go over the test with you guys as well and talk about retakes, but I'll do that during the Zoom. So let's go back to this. We learned this back in geometry. So what we're doing today is we're going to be simplifying square roots. Okay, we've done that before and we did this in geometry, but at the same time we're going to talk about rational, that's on the other side, rational exponents. So rational exponents, rational means fraction, so we're going to have fractional exponents, which is what we're going to look at on the second page. So let's go back, let's take a journey back to geometry. So in example 1, you could take the square root of 27, and the square root of 27 is a pretty ugly number. If I just do square root of 27, it's an irrational number. Okay, this is an irrational number because it's a decimal that never ends. Okay, so what I want to do is rationalize it. Okay, so I want to try and break it down as much as I can. So we do this in geometry. I'm going to take the square root of 9 times the square root of 3 as the multiples of 27. The reason I want to do that is there is a square root of 9. It's just plain old 3. I'm going to take half of the exponent. Okay, we're going to take half of my exponent because x to the fourth times x to the fourth will equal x to the eighth. Okay, so I'm going to take then half of this and have it as an x to the fourth. Okay, so then I'll finish it up by taking the square root of 9, which I know is 3. I like to cross out when I do it. Square root of 9 is 3. X to the fourth is no longer square rooted, so it comes with the 3. Okay, I took half of it, so it's been square rooted. And then what's left over is this square root of 3. And the square root of 3 is another irrational number, 1.73, blah, 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 another irrational. So we have to leave it either as this ugly decimal, which we don't want to do, or we just leave it as the square root of 3. Okay? And again, we did this in geometry last year. So there we go. 3x to the fourth, square root of 3. That's my reduced answer. Okay, number 2. In number 2, I have a 3. The 3 is a regular 3, so I'm just going to write that down. It's done. We're going to do something with it later, but there's no square root to it. Okay, it's just a 3. But 18, I'm going to try and find two numbers that make 18. Not 6 and 3. Not 6 and 3, but 9 and 2, because 9 has a square root. Okay, not 6 and 3. And then the problem with this, I want to take half the exponent, so what I'm going to do is I'm going to take 1 away. 1 away. And watch what I do. If I take 1 away from 7, watch what I do. Square root of x to the 6th and square root of x to the 1. By taking 1 away, I've made an even number. When I get my even number, I can take half of that exponent. Okay, so whenever I have an odd exponent, if I take 1 away, it makes it even, and I can take the square root of it. Because remember, the tiny little invisible 2 here that we never write, but we know we're going to take half of, because it's square root is a 2, half of that. Let's see what we got. This 3 is already there. Square root of 9, I'm going to take the square root of 9, and it becomes 3. Square root of 2, I'm going to leave it alone for a second. Half of that makes an x to the third. And then these two, square root of 2 and the square root of x, we're going to leave as is because we can't take the square root of it without getting ugly numbers. And then finally, 3 times 3 is 9. X to the third, square root of 2x. Okay, again, we did this last year, so hopefully this is a review. Okay, example 3. If they're both square roots, we can multiply them. We can. So I'm going to get the square root of 75, which is 15 times 5. And then I'm thinking, wait a minute, I bet I can break that down. I know 25 times 3, square root of 25, square root of 3. Square root of 25 and 3 makes 75, and I like 25 because I can take the square root of 25, have 5 square roots of 3. Again, we did this last year. Hopefully this is just a nice review. Okay, number 4. If I'm going to multiply, then I'm going to multiply my regular numbers, my whole numbers together. 2 times 4 is an 8, and I'll multiply my square root numbers together. Square root of 3 times square root of 6 is square root of 18. Now again, if I've got a square root of 18, maybe I can reduce it. I'd like to reduce it by finding good multiples. Well, I did that already up here, didn't I? 9 and 2. So leaving the 8 out there, and change the square root of 18 into the square root of 9 times the square root of 2. Not 3 and 6, not 3 and 6, because square root of 6, square root of 3 can't be square root, so don't do that. Okay. Square root of 9, I can do that. Okay, leaving my 8 alone. The square root of 9, I can do that. The square root of 9 is just going to be a 3 times 3, because it's all multiplied. Square root of 2, and finally, 8 times 3, these are whole numbers, is going to be 24. 24 square root of 2. That's the answer I like, okay? I've taken this multiplication process and reduced it significantly, much better. Now, in example 5, we did this last year. You cannot add them unless they're the same. They're not the same. They must be the same. Must be the same to add or subtract, okay? Has to be, okay? And they're not. But if I reduce them, if I reduce the 8 and reduce the 18, maybe they'll become the same. So let me try and do that. So the 3 is just a regular 3. I'm going to leave that alone. Square root of 8. Let's see. Square root of 8. I'm going to change that to the square root of 4 times the square root of 2. Because 4 times 2 is 8, and I can take the square root of 4. Okay, the 5 is on the outside, so I'm going to leave the 5 there. And then the square root of 18. Let's see. We've been doing that one. That's going to be 9 and 2. Not 3 and 6. Square root of 9. Square root of 2. Okay? Why not 3 and 6? Because there is no square root of 6 and there's no square root of 3. That's why. But there is a square root of 9. Okay, so let's keep going. So 3 is just a regular 3 whole number. Leave it alone. Square root of 4, though, I can do that. What's the square root of 4? 2 times 2. Square root of 2 is just an ugly, irrational number. Keep it a square root of 2 plus. Keep down the 5 as a whole number. Square root of 9, I can take the square root of 9. Becomes a 3. And then I get the square root of 2. Now, all right, let's see what I get. Oh, hey, they're both square roots. So let's simplify this. 6 square roots of 2, because 3 times 2, plus 15 square roots of 2, because 5 times 3. And now they're the same. I can add them. Must be the same to add. I can. 6 square roots of 2 plus 15 square roots of 2 makes it 21 square roots of 2. And that's as far as I can go with this, because square root of 2 is an irrational number. Cannot be reduced. Okay? Awesome. Now, moving on. Number 6. Let me make these parentheses bigger. You know, when I type this up, I can't make them that big. But I am going to distribute this times this, and this times this. Okay, regular distributive property. So when I do this, whole numbers to whole numbers, it gives me a 6. 3 times 6 is 18. Square root of 18 plus 3 square roots of 3 times 5 square roots of 3. If I multiply, I go 3 times 5 is 15. Multiply my whole numbers. Times 3 times 3 is 9. Square root of 3 times square root of 3 square root of 9. Now, there's some things I can do with this, right? Obviously, the easiest is to make that 9 into a 3. I can do that right off the bat, okay? Plain old square root of 9 is just 3. Now, however, the 18, we've broken that up above several times, so keep the whole number. Square root of 18, I'll go square root of 9 times square root of 2, not 3 and 6. And then, again, what I can do is take the square root of 9, which is going to be a 3. So I'll get a 6 times a 3 times the square root of 2. And then these two I can multiply to make it a 45, because those are whole numbers. Finally, to finish it up, I'm going to make this an 18 square roots of 2 plus 45. Now, don't add them. Do not. No, 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 no. That's your answer. That is it. Don't add these, because that's a square root of 2. And this doesn't have any square roots of 2. So that is your answer. 18 square roots of 2 plus 45. Okay? That's a bunch of square roots of 2, and that's a 45. Don't add them. Okay, number 7 is basically a FOIL problem. You know, this times this, this times this, this times this, this times this, right? So let's take a look at it. So I'm going to multiply whole number to whole number. So 2 square roots of 3 times 5 square roots of 3 makes a 10 square roots of 9. Okay, then 2 square roots of 3 times negative 5. Whole number to whole number, okay? So I'm going to get a negative 10, but I have to also have the square root of 3. Have to also have the square root of 3, okay? And then the inside, 1 times 5, multiply the whole number, so I get a positive 5, but I also have to multiply by the square root of 3, so there's my square root of 3. And then finally, 1 times negative 5 is negative 5. Okay, is there anything I can do? Sure. Sure, there's a bunch of things I can do to simplify it further. I know that the square root of 9 is just 3, so let's bring down my 10. Square root of 9 is 3 times 3. Now these two square roots are the same. They can be combined to make a negative 5 square root of 3. Okay, check it out. Negative 10 square root of 3, positive 5 square root of 3 makes a negative 5 square root of 3. Then minus 5. All right, now, multiply a little further. Okay, 10 times 3 is 30, minus 5 square root of 3, minus 5. All I did was 10 times 3. That's it. And the last thing I'll do, is I'll put the two whole numbers together. I've got 30 minus 25, 30 minus 5 makes it 25. Bring down the minus 5 square roots of 3. I cannot subtract them because they're different. That's a 25 and that's 5 square roots of 3. They're different, so that is your answer. Don't subtract those. They're different. Okay, now, that's a review of what we learned last year. So then what about today? Okay, well, what you're going to see today more has to do with exponents that are rational exponents. So let's take a look at this. So here's a little rule. Write this down somewhere. We're going to have x to the p over q. So that is what we call a rational, oops, you can't see it. That's what we call a rational exponent, okay? That's a rational exponent because the word rational means fraction. So we've got an exponent that's a fraction. So we're going to rewrite this. So the bottom number is the root and the top number is the power. Okay, so I'm going to rewrite this as the q root of x to the p power. Okay, I'm going to highlight that because that is like the lesson. That is the biggie, is this little transition from exponential form into a root form. Okay, so then what I'm going to do with that is take a look at example 8. So in example 8, I just want to simplify this a little bit. So if I simplify it a little bit, let's see. That's my root, and that's my power, my root and my power. So I'm going to go the fifth root of 32 squared. Okay, now I can actually simplify this using my superior brain because we all have brains that are superior. Okay, I'm going to do this first. What is the fifth root of 32? Let's think. Let's think, what times what times what times what times what? 5 of them. What times what times what times what times what makes 32? Well, it's got to be 2. 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. So I'm going to get a 2 to the second power, and 2 to the second power is 4. And that is the answer. Okay, number 9, we can do the same thing. Okay, I'm going to rewrite this. Oh, I'm not going to rewrite it. I'm just going to go ahead and do it. Okay, I can do this first. So, what times what makes 27? What times what makes 27? Well, that's got to be 3, because 3 times 3 is 9 times 3 is 27. So I'm going to have a 3 squared, which is 9. Okay, there you go. Now, 10. How do you solve for x? Well, whenever we undo things, we always do the opposite. But let's do first. Let's divide by 2, and I've got x cubed equals 30. Okay? Now, depending on what we want, sometimes a decimal answer is okay, sometimes not. But in this case, let's go ahead and get a decimal answer. So let's go to the nearest tenth. Because what I'm going to have to do is undo it. So how do I undo this? Well, here's what I know. If I take the cube root, of x to the third, then it's like the opposites of each other. So the cube root would cancel out the cube, and I'd be left with an x. So I do the opposite. Always do the opposite to solve, right? To undo it. So then I also have to do the cube root of 30. And so then what is the cube root of 30? Well, one answer is we can leave it like that. I would accept that in a test. But, you know, if we want to go to the nearest tenth, so I have in my calculator a root button. Go to math, and there's my cube root. and I'm going to go cube root of 30, and I get an answer about 3.1. So x is equal to about 3.1. Again, I use my calculator, and I don't know if you have fancy calculators. Some phones will do it. Your phone will if you check on your phone, but you have to turn your phone sideways to get it, okay? So, you know, on my cell phone, I've got an iPhone. I know we all have our preference, but if I go into my math, school, calculator, okay, so if I take my phone and flip it, come on, flip for me. Get the setting. Well, anyway, you can flip it and get the root buttons. Okay, anyway, I'm going to have to fix that. I never worry about it because I always have a good calculator. Okay, example 11. So let's undo it. So since this is all inside the square, to undo it, we'll square root first, right? We'll square root because it's the opposite of squaring. So if I square root this square, it'll cancel out the square, but I also have to take the square root of 50. So I get x minus 5 equals the square root of 50. Now, I'm going to reduce it so I have a nice answer. I don't want a decimal answer. So here's what I know. I'm going to go plus 5 plus 5. And I'll have x is equal to 5 plus the square root of 50. But what I know is that 50 can be broken down. 5 plus, well, 50 can be the square root of 25 and the square root of 2, right? 50, 25 times 2. 2 quarters make 50 cents. I can then take the square root of 50, and I can have an answer of 5 plus 5 square roots of 2. Now that seems like an odd answer, but it's a very accurate answer, because the decimal I would have had would have been something like this: 5 plus the square root of 50. And instead of getting an ugly decimal, I don't really want an ugly decimal. I want a beautiful mathematical answer. Okay, that's all I have. The homework's out of the journal. Make sure you guys look at it. I'll show you real quickly so you don't make any dumb mistakes. That's what I do all the time. I make the dumb mistakes. You guys never do, of course. So on the homework, you got to be a little bit careful, because on number 1 it says the indicator root. So they want you to take the cube root of negative 125. They want you to take the square root of negative 400. Impossible. Can't do unless you use I. You can use I. You can do a 20i, right? You want you to do the 6th root of 64, okay? And all the rest of these, they just want you to do without a calculator. Square root of 64, cube root of 127th, and so on and so on, okay? Anyway, and then you got some solving. So that is the homework for you, okay? I will talk to you tomorrow.